You guys got stuck. Okay, I tried to develop that blog site for those of you that could go there and help. Okay, how many of you went there last night? Did you sign up for the extra credit?
Yes, I did.
Okay, very good. Okay, I will randomly do that because it has to become to a point that some of you, when you get to a point that I can't do it, it's easier to give up because I can't get it than to try to find help, because trying to find help takes more effort, more time, okay, and something that, I've taken the time and effort to provide this way to get help. There's many different ways to do it in this class, okay. I have before school, I have after school, okay, I have that blog site there, okay, you can watch the videos, okay, all of those things are ways to be successful in here. Okay, and I just want to make sure that you're taking advantage of all of them. Okay? Alright, so what you see in front of you right here is something the district has adopted for the high school as well. Yes, some of you have done it. Some of you have done it, okay, years past in middle school. All you have to know is that it's due on Friday. Okay, we'll go over it. I'll give them out Monday. I was supposed to give it out Monday and forgot. Okay, so it is due on Friday. So go ahead and put it away. Maintain your skill stuff, 12 problems. We're 12 points on Friday. Okay? You need to show your work. Okay, to get credit. Okay, as you go through it. You need one more? Okay. Alright, yesterday, how many of you guys, did anybody get stuck on that finding the center of the circle one? No. Did you guys try to use a coordinate plane when doing it? To graph it? No. Because if you did, I think that circle's literally this big.
I figured out that you need 2 seconds.
Okay, all I really wanted you to do, it's number 6, right? Okay, on that worksheet right there, is all I literally wanted you to do is draw a picture of a circle. You don't have to use a coordinate plane. You don't have to put them in the right spots. If I remember right from helping people this morning, weren't these the points A, G, and D on there? Weren't those the points? Now they have coordinates. I don't know them off the top of my head, but I'm just going to kind of talk you through it here so that you can organize your work. If you want to find the center, don't you have to perpendicularly bisect a chord? Mm-hmm. So that means you probably have to find the slope of a chord. Okay, find the midpoint of that chord. Then, if you had a slope and you have a point, I think this equation is the easiest one to use. Point-slope form. But be careful, do you actually plug in the slope right there in 4M? Okay, this right here is the perpendicular slope, okay, because this had to be a perpendicular bisector of it. Now, you could pick any 2 chords. I did A and G, just drew them up there. Okay, maybe you did A and D. Maybe you did G and D there next. And you do the same thing again for that. Okay, and then you take, once you have these 2 equations, okay, you have the red equation, okay, and you have the blue equation. And I think you may put them in that form to start off with, but what do we have to do then after that?
Put them into y equals.
Why do we want to put them into this y equals form after that?
Because then you can set up the x and the number equal to the other x and the number. You get 2 y equals equations.
Okay, so then you can solve for x by setting them equal. So you get that first equation that's there in red, okay, and you set it equal to that second equation that's there in blue. And I think that's easier once they're in this format to set them equal, right? Okay, but I think it's easier to put it here, distribute that m, okay, bring that y over here, and then set them equal to each other. Okay, you could use elimination, but it gets a little bit tricky in doing it. I would not recommend that. Okay? All right. Today, anybody have any questions there about that? Today, in the last 10 minutes, it was supposed to be the whole period to work on the rest of this worksheet. So because Thursday's going to be a shortened period because of the academic assembly and because of today's shortened period. Okay, all I want for tonight is you write down we have to have, of those 11 problems, you need to have 9 of them done correctly. 9 of them done correctly. You should have 5 done already, right? Mm-hmm. So that only leaves 4 for tonight. And I know one of them's like a minute problem to do. Okay? So that really only leaves 3 of them left to do. Okay, you can pick any of those 3. But it is worth 6 points tomorrow. Okay, so use your resources, whatever it is, if you get this, if you get a jam. Okay? You come in the morning, come in after school, okay, blog, you can call your friends, I don't care. It's, I'd prefer if you are going to carry a conversation on, instant messaging, you do it right there on the blog site, so if others get jammed, I can see. I tried to reply to the very few that were there last night. Okay? All right? Any other questions? No? All right, before I let you work on this assignment, then, I have my second conjecture that I have to cover. Okay? So go ahead and take out a sheet of paper here for notes.
Can't wait for your second conjecture.
My second of 4.
You did not make up all these conjectures.
Second conjecture of 4. Is it in the textbook? Then it's mine. Exactly.
Google.
All right. Our first conjecture dealt with, my first one dealt with a secant angle, correct? But where was that secant angle at? Outside. And I believe if I take this big arc and I take that small arc, what do I have to do to those big arc and the small arc? Subtracted them. I did that right there and I got 52. Okay, but my angle was 26. Would I have to do the angle to get the subtraction or the difference of the arcs? Okay, I don't like divide the arcs because what happens when all of a sudden I put the algebra in there? Do you guys really want to divide algebraic expressions by 2? No. So I create a good habit by always saying, let's double the secant angle. So that way we kind of don't get a jam then when you did see some of those algebra ones the last couple days, right? Okay, so it's not a big deal, but it's a good practice. Okay? But the question that I'm going to have today is, you guys watch right here. Okay, as I animate this thing, okay, as I go through, you guys are seeing right up here, okay, those numbers right there are staying the same. Minusing this arc, okay, doubling that arc's the same until what happens? These aren't the same anymore. Why are these no longer the same? Because that secant angle's inside. This subtraction of the arcs only works. Okay, it's only going to work, okay, when this secant angle, okay, is outside of the circle. Okay, it'll work. I gotta get this moved here, right? There we go. When it's outside the circle there. Okay, what did I click on? That's wrong. I think I have a measured. I moved a point up there. My arcs are here different. The question that I'm going to have right up here is, okay, then what's going to happen, okay, when this thing goes inside the circle? Okay, what's the conjecture going to be, okay, when this thing all of a sudden, okay, gets inside the circle? I'm just going to quickly move it there. It'll go a lot faster. Like that. And like that. Okay, we're going to have 2 arcs still, right? Okay, so if I come up here and I'm going to measure this arc right here, I think that's the 2 arcs right there. Nope, I got some. I'm just going to remeasure the angles because these are all screwed up right now. Okay, so if I measure that angle right there, okay, that gives me 48 degrees. I don't know if that's going to give me the right. Yeah, it gave me the 32 one. Okay, and that one right there is 64. I'll make some nice numbers up here for us. Here's 80. And we'll make that one 30. It's not the best. Okay, but if I add 80 and 30 and 55, here was some of them that I had last hour that worked. We'll add ours in there. 80 for the big arc, 30 for this one, and 55. Okay, some of them I had last hour, and you can just kind of look up here so we kind of quickly going to go through that. If the big arc was 100 last hour, the small arc was 50, the secant angle ended up being 75. And you can obviously see 100 minus 50, that's 50. Well, 75 is already bigger than it. Now I had 80 and 60. Well, that gave me 70. I got 100 and a 20, and the secant angle last hour was 60. See if you can discuss in your groups right now, okay, what you're noticing there, okay, about the conjecture.
The mean of 2 arcs is equal to the secant angle.
It's like the same thing. So it's just divided. The secant angle is closer and
No, the mean of the secant angle is just as good.
All right, this one right over here. The only big difference is anytime I did this, and you can kind of look at the numbers I have up here, if I add 150 together, I get 150. What did I have to do to the 75? What did I have to do to the 75 up here to get the sum of the two? Double it. So is that anything different? You still do the same thing in the secant angle, right? But what's the big difference here in my second conjecture? We're adding it. Okay, so no matter what your measurements were, when you add them, you'll get, okay, the secant angle times 2. Okay, we can check that out right up here to see if that works. Okay, as I animate this, you're looking at these numbers right here this time. Okay, you can see they're staying the same. Okay, as that secant angle remains inside the circle. Okay, these numbers right there are continuing to be the same. Okay, but once, okay, that angle gets outside the circle, which is going to happen right here in a little bit, are these numbers up here anymore the same? Why is the arcs added together not the same as 2 times the secant angle? It's outside the circle. Okay, it should get back here as it's animating here. It should get back inside the circle here, and once it does, okay, you should see, okay, those numbers, and I have to get the numbers back. That's how I clicked on the arcs. Okay, they're good now. Okay, it just depends on where I clicked on that. Okay, and you can see they're the same.
The numbers.
Okay. All right. So on that sheet of paper, okay, you tell me what the conjecture is using that diagram. What is my second conjecture? Okay, using that diagram. I told you my second conjecture using that last picture. Using this picture and circle P. What's my conjecture going to be? Which arc plus which arc did you guys do? I'm not asking you to find any arcs. I just want to know which arcs you would add together.
See which ones you're doing.
So the conjecture you guys looks on some of your faces right now, it's no, that's not what I wrote down. Okay, A, D, B, C. You can flip them around, sure. Is that what you guys put down?
Yeah.
No? So that's not my conjecture?
No.
It is.
That is my conjecture.
But you can do blind.
So the question that I'm trying to watch up here is that you got to, when this is inside, isn't there two sets that you could possibly use my conjecture on? If you came over here and you used 2 times angle BEA, if I wanted to find angle BEA, or if I was given arc BA or something like that,
Right.
I think add more of you put this. Right?
Um,
But are both of them my conjecture?
yeah.
Does it work?
Yes.
The second one?
It does, because if you find
The first
if
one.
you find this first one right here, what's going to actually be true about those 2 angles? They're 180 because they're supplementary. It's all going to work out the same. Okay, it just depends on what information did I give you in the picture. Okay, like in this one right, so not this one. This one right here. Okay, what information did I give you in the picture? You know, you've got to decide, okay, which set am I going to use? I have the red set, or I have the green set.
Things.
Mitchell, which set seems logical to use on this example right up here? The green. Okay, I would agree. If I'm going to take BC, oh, I forgot. Do you add or subtract these things?
Add.
You know, it's pretty silly for me to say I forgot them 5 minutes ago, but how about, you know, tomorrow's quiz? Are you going to remember that they add or subtract? Yeah, you guys heard that, right?
No.
Alright, so maybe do we add or subtract them? How do we remember? You know, I forgot. I can't remember if it's inside. Do I add or subtract them? Every year I always have somebody, okay, look up here and think of a mnemonic device, okay, for us. That's pretty obvious that we can remember. When they turn out like this, we're always going to add them. Jamie, you're pretty good at these mnemonic devices.
Yeah, I don't know. Like, when they crossed it, it was a plus sign.
Does it kind of look like a plus sign?
No.
And I think that's what everybody looks like there. Okay, is that it kind of looks like a plus sign. Okay, when we're there. So we remember to add them. Okay, when it's inside like
Got
that.
one.
Okay. I don't even want to
Oh,
hear
come
you,
on,
John.
come on.
All right, John.
All right.
What is it?
You know
This is
how
going to
if
be
you're-
more complex than I need to remember.
Yes.
It's just flat out.
If you're in the loop, like
Yeah.
it's all good. It's like loops like a circle.
Uh-huh.
And adding, everyone likes to add. So if you're in the loop, it's good, so you're gonna add. But if you're out of the loop, then it's bad, and you gotta subtract.
It's a good mnemonic, but I think I like the plus sign a lot better.
No one likes the side.
All right. So this one right up here, I have BC plus AD equals 2 times angle. Now, I talked about this yesterday. Some of you are going to come up here and just say, I just want to take 2 times 50 and subtract 34. Once I start putting the algebra in here, once I start relating all of my concepts together, okay, you're going to want to stay consistent on how you're solving them. Okay, and it doesn't take much to come up here and subtract, okay, 34 from 100. So AD, okay, is going to equal 100 minus 34, which is 66 degrees. Okay, you know, I even skipped a step there of doing the 2 times 50 because I thought, you know, we could at least show that, okay, 2 times 50 is 100. Put it off here to the side if you wanted. Subtract the 34. At least you're showing it there. Okay?
Yeah.
Alright, before we do this last example, my circle rules. Last night, problem number 1 and 2. Did anybody get stuck on them?
No.
Like,
They're pretty easy.
number one
No.
is hard.
When you get stuck on these puzzle problems like this, What's the number one I call them my Waldo rules because of the fact it doesn't matter how intelligent you are sometimes in doing these. I could get a new problem like this, and sometimes I have to stare at it for a while. Doesn't matter sometimes when you find Waldo once. You stare and you can't find it this next day when you look for it. Sometimes that happens to me every year. How did I set this problem up again? So what's the number one rule that we use? Diameters. Let's write them down. I got them right over here. I put them right underneath my Waldo sign from last year. Okay? But you're not going to have this for a test. But if you haven't written them down somewhere in your notes, let's do it now so you have them. Okay, our circle rules. Number one, okay, is that we have a diameter. Okay, I'll put them up here for you so if someone's watching this lesson right here, they will know my Waldo rules. Okay, 4 circles. Okay, first thing that we have is we look for diameters. Diameters have a tendency to hide things. Now, if you ever find a diameter, that's great. If you don't find anything from that diameter, go on. And I want to look for an inscribed angle, or not an inscribed, but a central angle, but more specifically, in that central angle, do you make an isosceles triangle? Now, I do want you to realize that if you don't start over and see if the diameter, if that central angle helped by the diameter, you're going to get puzzled as you continue to go on. Okay, so once I find the central angle, I'll go back and say, okay, now can I find more information from the diameter? If not, I'll go to step 3. And I'll look for an inscribed angle. If I find some information from an inscribed angle, I will go back and I'll say, okay, now does my diameter help me find some more information? Does my central angle help me find some more information from the inscribed angle that I found? And if it doesn't, I go to step 4. Okay, step 4. Okay, was my first conjecture, which was the secant angle. Okay, and that secant angle has to be outside the circle. If I find a secant angle, then I'll come back up here and I'll see, okay, can I use some information from the diameter now with what I found from the secant angle to find more? How about, are there any central angles from that secant angle? Or inscribed angles? Okay, and now, today, okay, you have my second one, which is when the secant angle, okay, is inside the circle. Okay, inside the circle is when it looks like this. Outside the circle is when it looks like this. Okay, and I still, once I find this next one, I will come up here and, okay, test all the other ones when I'm done. There is no good way to give you that visual acuity and be able to see the puzzle. Some of you last night, when you looked at that worksheet problem 1 and 2, would love to have thrown it away. Okay, or, got really frustrated at it. Okay, some of you enjoy those puzzles. Okay, same thing on this next one right here. Okay, if I have, it starts looking a little bit more interesting as I do this. Okay, I want to find CB's length. So go ahead, quick draw a picture right here, just sketch that down and put the information in there. Okay, you don't have to write the givens down. All I'll do is I'll help you as you draw the picture, put the information in there. CF is 42 degrees. AB's arc is 38 degrees. And angle DHF is 50 degrees. Now I'll talk about the last one here once you get your picture kind of drawn. Now, this one right here, I usually don't have that in my Waldo rules. So if you automatically see that in your picture, okay, I would automatically come up here and I would highlight those things right there. I would make sure that I mark them in my picture because a fact is something that can be easily overlooked because it's not in step 1, step 2, step 3, step 4, step 5. Because it's a specific case that may happen just in that one problem. What's true about parallel lines? The arc's inside, so this right up here is also going to be 38 degrees. Okay, so we go through my rules and I say, is there a diameter up here?
No.
There's no center, so we don't know. Since there's no center, there's probably no central angles. Okay, how about inscribed angles? Is there any inscribed angles? No, the inscribed angle I'd have to, that'd be an inscribed angle right there, so that is nothing there. Okay, then I go to Johnson conjecture number 1. Secant's outside, nothing extends outside. So now I'm to my second conjecture. Okay, and I actually see 2 of my angles, number 2s, right? Secant angle 2s, aren't there 2 of them? Mm-hmm. So the thing we have to decide here is which one of them do you use? Do you use this secant angle or do you use that secant angle over there? Okay, and since I kind of gave you this 50-degree angle here, I'm gonna mark it. You guys see how I'm marking it? This is where I like my highlighters to be able to see how it pops out. Okay, and I can see, oh, okay, I do have enough information right up here. Okay, because if I come up here and I have DF plus BC, I'll get 2 times angle DHF. Okay, DF, okay, looks like it is 80 degrees. Plus BC, I don't know it. You can put X there if you want, or just BC. Equals 2 times 50. Okay, I subtract 80 from 100 degrees, and I get BC's arc to be 20 degrees. Okay. Now, I asked this last hour, and man, I did not anticipate this next question of how someone would answer it. And I liked it, so I'm going to ask it again. What happens if I ask for the secant angle right there? Could you find it? Angle CIA? CIA. Yeah, CIA. Can you find that angle CIA?
Yeah. Now. Right
You
now.
can now?
You can find it before.
You couldn't find it before? I had to find CB first?
No, you can do it. It's parallel, so it's transverse.
See, I didn't think of that. These are parallel lines, so this is 50 degrees right there. You guys realize what I did here is I took this arc out here, which I now know, since this was 20 degrees right here, I took, okay, this whole arc right here, which is 58, took 58 plus 42 degrees, that arc right there, 42, okay, divided that by 2, and that gave me my secant angle, okay, which is still 50 degrees there, okay, because that's 100 divided by 2. That's how I meant the question to be asked until I realized, why would you do that? It's quicker just to see the alternate interior angles, okay, which was good, okay. All right.
She has extra credit to listen to this long for 20 minutes.
Yeah. Anybody have any questions here on the second conjecture? All right, 9 problems I told you from 7.6 worksheet done correctly. That's worth 6 points. One tomorrow, the assignment is wise. I would find the problems you didn't get last night. You got stumped on some. Why don't you work on it here? We got about 10 minutes here in class to work on those. Okay, if that was the spike the center, or if that was the puzzle 1 and 2 problems that you guys got stumped on. But 9 problems done correctly, and I think number 7 may be a quick one for you to do. Okay? So you really only have 3 more to do. That is if you got them all done last night.